Dear students, in this class we will discuss about how we can produce and detect or analyze plane, circularly and elliptically polarized light. In the last class we have detailedly discussed about how the plane polarized light can be achieved. There are different methods: by reflection, by refraction, then by double refraction. From these methods we will get plane polarized light. And another method we need to discuss is polarization by dichroism. It is one of the method by the selective absorption of the ordinary ray or extraordinary ray. That is the selective absorption. That is, certain materials that can absorb, or the materials that have the property of absorbing ordinary ray or extraordinary ray unequally. So the property of absorbing the ordinary ray and or extraordinary ray unequally, that property is known as dichroism. Tourmaline crystals that exhibits the property of dichroism. As a result of this selective absorption, plane polarized light that is emerges through them. Here the unpolarized light. For the ease of the understanding, I just draw two components. One component that is parallel to the optic axis and another is perpendicular to the optic axis, and if it is incident on the crystals that have the property of dichroism, or if it is incident on the tourmaline crystals, see the one component that is perpendicular component, that is the amplitude of the component that is reduced to 0. Only one component that is emerges out the crystals. From this way we can generate plane polarized light. So when unpolarized light that is incident on the tourmaline crystals, it is split into two components, that is ordinary and extraordinary. Both of them are polarized, but these crystals selectively absorbs one of the components, so the only one component that is emerges out the crystals. This phenomena of this selective absorption, or the phenomena of dichroism, that is used in making Polaroids. Polaroids, that is a device by using the principle of the dichroism. It is one of the cheaper polarizer. Here we can use, or we can make this Polaroid film by paste one of the compound, that is quinone iodosulfate, between the two glass plates, and that glass plate, that is the film sandwiched glass plate, act as the Polaroids. Herpath and they are successful in producing such a synthetic crystals of this iodosulfate film between the glass plates. So these crystals absorb one of the component of the unpolarized light. And another Polaroids, that is the PVA films, that is polyvinyl alcohol films. If we stretch this film of PVA, that can be used as the Polaroids. As the stretching of these molecules, they are arranged with axis parallel to the direction of their stress. So these crystals now act as the Polaroids. So this Polaroids absorbs the components of the light. So these Polaroids can be used as glass windows in trains, aeroplanes, so, to control the intensity of the light emerges, or intensity of the light emerging from the outside. Just control the intensity. And also these Polaroids can be used as sunglasses. There are polarizing sunglasses, they are available, that is used to cut off the glares of the reflected light. And another application is it is used in headlight and windshield of automobiles to eliminate the glare. And it is also used to improve the color contrast in the oil paintings. And it is one of the best device to obtain the three-dimensional effects. If we view the stereoscopic motion of the pictures in which three-dimensional effect is experienced, we can use these Polaroid films. And these are the methods for producing the plain polarized light. And next, our next strategy is to find out how we can analyze our produced light, that is, it is plain polarized or not. How we can analyze the plain polarized light. The analyzing of the plain polarized light, that is, it is very simple. If this plain polarized light, this is the plain polarized light that is allowed to incident on the nickel prism. Here the nickel prism acts as the analyzer. Now we just rotate this nickel prism about the incident ray as axis, just rotates this nickel prism. Definitely there is variation of the intensity of light emerging from the crystal or emerging from the analyzer. That is, this intensity varies from maximum to minimum or 0. From this way we can understand the plain polarized light emerges from the crystals. That is, if we place this picture, that is unpolarized light is incident on the tumbling crystals, we will get plain polarized light. If we need to analyze whether it is plain polarized light or not, the method is just place one nickel prism, and this plain polarized light is allowed to fall on the nickel prism, and we just rotate this nickel prism. So the intensity varies from maximum to minimum. From this way we can understand the emerging light is plain polarized light. Then how can we understand the elliptically polarized light, or how can we produce the elliptically polarized light? Actually, this elliptically polarized light, that can be produced by two waves of unequal amplitudes. See, this is the elliptically polarized light. It has minor components and major components. To have the unequal amplitudes having the vibrations at right angles to each other and phase difference of pi by 2. Phase difference pi by 2 means path difference lambda by 4 between them. Now how can we produce this elliptically polarized light? We can see. We just allow to fall the unpolarized light that is incident on the nickel prism. If we allow to pass the unpolarized light into nickel prism, what happens? This ordinary ray that get reflected, only extraordinary ray that is allows to pass through it. We will get plain polarized light. Now plain polarized light that is made fall normally on this quarter wave plate. And keep it in mind that this amplitude of the lattice vibrations making an angle other than theta, that is other than 45 degree, 0, 90 degree with the optic axis of the crystals. What happens? This plain polarized light that is split into two components, ordinary ray and extraordinary ray. Both these rays travels along the same direction with different velocity. This angle of incidence, or not the angle of incidence, it is fall normally on the crystals, and this amplitude of the lattice vibrations and makes an angle other than 45 degree, theta or 90 degree with the optic axis of the quarter wave plate. We will get unequal amplitudes. What happens if we plan to make an angle 45 degree? Definitely we will get equal amplitudes. For obtaining the unequal amplitudes, make sure that the angle other than theta, that is equal to 0 degree, 45 degree and 90 degree with the optic axis of the quarter wave plate. Okay, now we will get two rays with unequal amplitudes having the same frequency and period or period. Now to analyze the elliptically polarized light, it is observed through the Nicol prism, that is N2. We have used another Nicol prism N2. We just rotate this Nicol prism here. The intensity varies between maximum and minimum. Note that this is not 0 because it has unequal amplitudes. So intensity varies maximum to minimum by rotating this Nicol prism. In this way we can identify the emerged light is elliptically polarized light. Now it is simple to find the, or simple to produce the circularly polarized light. That is just same like that elliptically polarized light. Unpolarized light, that is incident on the Nicol prism. Definitely plain polarized light, that is emerges out the crystals and it is allowed to fall on the quarter wave plate, makes an angle of 45 degree with the optic axis of the quarter wave plate. What happens? We will get ordinary ray and extraordinary ray with the same amplitude and period. So we will get circularly polarized light. Just like the elliptically polarized light, if we here we have used the Nicol prism to identify the whether it is circularly polarized light or not, we just rotate. But the interesting thing is that there is no variation in intensity. This is only the special case of the circularly polarized light. That is, if we place the Nicol prism after the circularly polarized light and just rotate the prism, there is no variation in intensity. See, when an unpolarized light that is incident on the Nicol prism, we just rotate, there is also no variation of intensity. These two cases are similar. Then how can we identify the incident light is unpolarized light or circularly polarized light? That is, for both these cases, we will get there is no variation in intensity. So one of the good method to identify the circularly polarized light is that is allowed to fall on one of the plate, that is quarter wave plate. So the output is linearly polarized light. So it is very easy to find out this light is linearly polarized light by using the Nicol prism. we just rotate, so there is definitely variation of the intensity between maximum and 0. So the introduction of the quarter wave plate to analyze the circular polarized light, that is the only the difference between the elliptically polarized light and the circularly polarized light. Then why we introduce this quarter wave plate? That is for identifying the circularly polarized light, because if the input, that is whether it is circularly polarized light and unpolarized light, if we rotate the nickel prism, the output is same, that is there is no variation in intensity. So we just convert circularly polarized light into the plane polarized light by using the quarter wave plate. Then it is easy to identify. Okay. In the next class, we will discuss about optical active crystals.